The first project with the FPGA and the board D10 Lite is a simple full adder implemented inside the FPGA. The full adder sum ups the first three switches inputs here. So 1 bit is 1, 1 plus 0, 0 is 1, and the result of the output of the full adder is 1. If another bit is 1, 1 plus 1 plus 0 is 2, and the output of the full adder is 2. And if the third bit is 1, we have the output that is 1 plus 1 plus 1. The result is 3. So I put down the switches. We also, of course, the output of the full adder is provided to another VHDL block that is a BCD to 7 segment block. And the other inputs of the BCD to 7 segment driver are the switch, the fourth one, that turns on or off the decimal point. Next, also this switch is an input because the BCD to 7 segment block has 4 inputs. 2 inputs are provided by the full adder, the other 2 inputs are this switch. So if this switch equals 4, while this other switch when 1 is equal to 8. So we can test all possible combination. For instance, 1 plus 1 is 2, plus 1 is 3. If we want the number to test the BCD to 7 segment when we have 4 in input, we turn on this one. Next, we have 5, 6, 7. We turn off. And if we want to test 8, maybe with the decimal point, for instance, we turn on the switch 8. And we can also test 9. And I also implemented other A as for 10, B for 11, and if you want 12, this is C for 12, 8 plus 4, and we can test also D for 13, E for 14, and F for 15. The decimal point, of course, is just the switch that can be turned on and off. This is the simple project we are going to develop now with Quartus and Questa on the D10 Lite board. First of all, I have prepared the VHDL file of the project in the project folder. So the first block is the full adder, and we can open it and it has 3 inputs, A, B, and C, that are the switch 0, 1, and 2. These 3 inputs are summed up, and the results of the output are the sum bit and the carry out bit. The architecture is very simple. The sum bit is the XOR of the 3 inputs, while the carry out, this can be a simple function, the OR of the hand of 2 different bits, input bits. This is the full adder. The output of the full adder is provided in input to a BCD to 7 segment driver. That is another block that has an inputs, 4 inputs. The least significant inputs, 1 and 0, are the bit sum and the bit carry out coming from the full adder, while the bit 3 and 2 are the switches 4 and 5 of the board, so are physical input. And this is the switch 3 of the board, that is the input for the decimal point to turn on or turn off. The output of the BCD to 7 segment driver is provided of 8 bits, Q from 7 down to 0, because 7 bits from 6 to 0 drives the segments. while the 8th bit drives the decimal point. So we have 8 outputs. Okay, we have to remember that the board, D10 Lite, has common mode anode 7-segment displays. So to turn on a segment, the input should be 0. The Q bit should be 0. So for instance, this turns on the segment A, this turns on the segment B, this turns on the segment C. The only segments that are not turned on are G and the decimal point. If you notice, the decimal point is never turned on. It's turned on at the end eventually, only if the decimal point input is 1. If this is 1, the input switch is 1, provides 1. 1, not 1 is 0, and this turns on the decimal point. So the architecture is very simple. There is a variable that is placed equal to the number in input, and according to this number, for 0, these are the segments that should be turned on. To display 1, these are only the segment B and C should be turned on. To display 2, only this segment here in 0 are A, B, D, E, and G should be turned on, and so on. So it is easy. And we also implemented the number 10 to display the capital letter A, the number 11 to display the letter B, the number 12 to display the capital letter C, and so on. Finally, the third file is the test bench to simulate before programming the board if the code is correct. And the test bench has just the output, the final output is the one we want to test, the output who drives the 7-segment display. And we have the two components, the full adder with its input and its output, and the BCD to 7-segment driver with its inputs and outputs. And we have the signals that, the stimulus signal that we set up to test all the possible configuration. So we simulate the signal A, we simulate the signal B, we simulate the carry in for the full adder, and we also simulate the BCD signals input to the 7-segment display driver. So you see there are the two block that we want to test as a full adder with its input A, B, C in, and the output of the full adder drives the inputs of the 7-segment display driver. So the carry out drives the input 1, and the bit sum, the output of the full adder sum, drives the bit 0. On the other end, the inputs of the BCD to 7-segment display driver are in the vector, standard vector in BCD. There is a decimal point input, and the output are the one we want to test. So the signal A changes every 200 nanoseconds. The signal B changes every 400 nanoseconds. The signal carry in changes every 800 nanoseconds. And the other signal we change are the bit 2 of the input of the display driver that changes every 1600 nanoseconds, together with the decimal point to test also how they work, and the last input of the BCD segment display that changes every 3200 nanoseconds. And this test of the possible configuration, it is sufficient to test the device with the first 4000 nanoseconds. And we do not change the output 1 and 0 because they are changed automatically when we change A, B, and C in by the full adder, because they are directed by the full adder. This is our project. So how to realize it, simulate, and program to the FPGA? We have to open Quartus. We create a new project. We can use new project wizard or file new Quartus Prime project. And next, so the folder is not this one. We are working to this folder. And what is the name of the project and the name of the top level? We call it DA10 Light 3. The name of the project, DA, this is DA10 Light 3. Top. Finish. We do not need any other things. Okay, here you see that is already inserted the device. Okay, then we move the visualization to files, and we can add the files to our project. So we can add our files from the list. So we can add the full adder. I can select it, apply, and we can add also the 7-segment BCD to 7-segment display. And we can select this one, apply, and we can add also the test bench. That is this one, and we can apply. Okay. Okay, we can also create the file from new. So if you want to create a new HDL design file, you can go here. I show it as an example. Okay. And for instance, if you have your HDL file already available, you can just copy it here, Ctrl+C, copy and paste here. And then you can save it with the name that you want to give to the project. So, for instance, I overwrite the original file, yes, and it